Acoustic measures of phonation focus on frequency or amplitude or both. The average fundamental frequency for a portion of speech uses the mean frequency of phonation based on the periods of the cycles of phonation in the quasi-periodic speech signal. The habitual fundamental frequency is taken from the production of a steady-state vowel, for example, asking someone to say ah. The speaking fundamental frequency usually comes from a reading task where you give a person a standard paragraph that they read, and you look at the fundamental frequency across that. You can also look at frequency variability, the amount of range of use of variability in the voice. Typically this is measured as the standard deviation of the fundamental frequency over something where you would expect some variability, like a reading task. You wouldn't normally expect someone producing a steady-state vowel, for example, to have a very wide range of frequency variability, so it wouldn't be an appropriate measure there. Something simpler than the standard deviation would just be to look at the fundamental frequency range from the minimum value that was produced to the maximum value that was produced. A different version of the maximum fundamental frequency range would be a task that specifically focuses on producing the lowest and the highest fundamental frequencies possible. Usually when you do a task like this, you have the person start at a comfortable frequency and then either go all the way up as high as they can or go all the way down as low as they can, and then look at the range from the lowest to the highest. That range can be fairly large, and to normalize for differences in basic fundamental frequency, the values for those frequency ranges are sometimes expressed in terms of octaves, which is a doubling of frequency, or semitones, which is a musical term. It's 1/12 of an octave if you want to give a fractional value. In looking at amplitudes for speech, you can look at the average amplitude for a speech sample. Generally speaking, conversational speech falls at an amplitude between 60 and 80 dB with a 70 dB average. Again, you could look at this as produced while reading a standard passage, for example. You can also look at amplitude variability, so how much variation in amplitude the person uses. Ordinarily, that's about a 10 dB range from the lowest to the highest. In more expressive styles of speech, like trying to tell an interesting story, you might have a greater range. If there's a very low amplitude variability, speech will sound monotone or very unemotional. You can also look at the dynamic range, the maximum range of amplitude from the lowest to the highest. So again, for doing something like producing an ah vowel, as quietly as possible while phonation is still happening, all the way up to as loud as possible, where a typical person's range is between about 50 and 115 dB. You can combine the analysis of frequency and amplitude together into a voice range profile. The voice range profile looks at ability to do minimum and maximum amplitude for a variety of different frequencies. So you start with the person perhaps at a comfortable frequency and have them do their lowest and highest amplitude, and then have them progressively raise or lower their frequency, and again go from the lowest amplitude to the highest amplitude. A typical voice range profile is shown here, where there is an kind of an ideal where they have the largest amplitude range they can produce. And then in the upper amplitude, there is a bit of a notch that occurs as the person switches from a more normal style of phonation to a more falsetto style of phonation. We can also measure very fine grain variability in either frequency or amplitude. These measures look at the frequency or the amplitude differences from one cycle to the next during phonation. So this would be 100 or more times per second while phonation is taking place. These measures, again, should be used on a steady phonation, so somebody producing something like an ah, and aren't really appropriate if the speech has natural variability in it. The jitter measure, which looks at frequency perturbation, analyzes how much variability there is from one cycle to the next in fundamental frequency. The speech signal is not a perfectly periodic sound, so there is some variability. Usually that variability is between 0.2 and 1%, and a value above 1% variability may indicate a dysfunction. So for a female speaker, for example, with a fundamental frequency of 220, you wouldn't expect the frequency from cycle to cycle to vary by more than about 2 Hz. Similarly, for amplitude perturbation, we have the shimmer measure, which looks at cycle-to-cycle variability in intensity, again during a steady phonation signal, one where you don't expect variability. And measures of shimmer or amplitude perturbation typically vary by less than 0.5 dB or 4% from cycle to cycle. Another measure of phonation quality is the harmonic to noise ratio. That is the intensity of the periodic part of phonation, the fundamental and the harmonics, to the aperiodic parts, the noise, in the production of a steady state vowel like or E. The harmonic to noise ratio, you look at the difference in amplitudes between the periodic and aperiodic portions in dB. If the harmonics are louder than the noise, that difference will be greater than 0. In a typical adult, that difference is at least plus 7 dB and maybe much higher, around plus 20. In studies of children and older adults, some lower values have been found. There aren't typically gender differences in harmonic to noise ratio, but females with a breathy voice would have more aperiodic noise components, and so they would be expected to have a lower harmonic to noise ratio.